Dear students, as you all know, as I promised, we want to complete work paper 1, understood, in 5 lectures. Lecture number 4 you attended, and now lecture number 5. Lecture 5 may be short because I want to deal with all those examples which none of is a part of your textbook. They are taken by me from other reference book, and it may happen that this type of examples can be asked in board exam. You cannot nullify the fact that this example hasn't been mentioned in the textbook and they have asked in the board exam. They can, because the examples which we are targeting from work paper 1 now are such examples which require a little inquisitiveness and little concept application by you. So you need to concentrate, dear student, in today's lecture number 5. Okay? Lecture number 5. First I want to target example number 17C. What is given in example 17? First you comfortably read the sum. It has been given that if sin B equals to what is given, read in the work paper, sin B equals to 1 upon 2, then find the value of, or prove that 3 cos B minus 4 cos cube B equal to 0. Let us start. They have already given value of one trigonometric ratio, sin B equals to 1 upon 2. What is the formula, dear student, for sin? It is opposite upon hypotenuse, as you all know. Now, dear student, I have intentionally taken this example because we are now targeting acute angle B. So you need a little modification in drawing the triangle. This is triangle, but you will name this way ACB because B angle you are targeting now. With respect to B, as you all know, this is opposite and this is adjacent. This is hypotenuse as ever. Opposite, that is AC, that is 1. AC, and this is BC. BC, that is 2. If you apply Pythagoras theorem, this is 2 square 4 plus 1 5. You will get AB as under root 5. What you require here is only one trigonometric ratio of our target. So let us take cos B adjacent upon hypotenuse 2 upon root 5. Is it clear? Now, dear student, concentrate here. What is LHS? 3 cos B minus 4 cos cube B. Okay. Let us put the value 3 cos B 2 upon root 5 minus 4 cos cube b 2 upon root 5 raised to 3. So this is now 6 upon root 5, 4 into c, 2 cube, that is 8. Root 5 raised to 3 means you can take root 5 how many times? 3 times. Twice root 5 means 5. So this is 5 root 5. Okay. Right, you got it? Now, cancellation is not possible here. So 4 8, this is 32 upon 5 root 5. Now just concentrate here. I think there is some mistake there, so 1 minute only. Just okay. Don't worry, just make a little modification. This is 1 upon root 2, I think, given. Just, dear student, make little modification. This will be under root 3. Don't worry, just make a little modification. This is under root 3. Okay. Here just write under root 3. And here also under root 3. Right. Cos cube b, not much need to be changed. Okay. 3 cos b minus 4 cos cube b. Is it any missing yet? Let me first verify it. If this is somewhere, just a minute, dear student, don't worry. Let me first verify if there is any mistake in giving the example. 3 cos b, okay, or 2 root 3, okay. I think a little mistake in giving the example. Just a minute. This is okay, 1 upon root 2, and that way we have taken already 1 upon, just a minute, dear student. Yes, we got the mistake which we have already done. Okay, let me verify it for you. Don't worry at all. Let us just have a little minor change in this. Okay, don't worry. Let us keep it as it is, right? What was that? 1 upon 2. Now, dear students, some mistake. Opposite upon hypotenuse, please, sorry for this. 1 upon 2. So, this will be hypotenuse, right? Okay. We just made a mistake. Now, if you take Pythagoras, 4 minus 1, 3, this will be under root 3, right? This was the mistake only. Now, cos b, that's adjacent upon hypotenuse, root 3 upon 2. You understood, dear student? We made just mistake by chance, okay? Right? Now, 3 cos b minus 4 cos cube b, that's LHS. Let us substitute the value. 3 under root 3 upon 2 minus 4. Understand? Under root 3 upon 2 whole cube. Okay. No cancellation possible. This is 4. Under root 3 cube means 3 under root 3 upon 8. Just cancel it. So you got 3 root 3 upon 2 minus 3 root 3 upon 2 turns out to be 0. That is equal to RHS. Little mistake, dear student, in just calculation. Just see it. Okay, first verify this example. Just a minor mistake we made in taking I took opposite adjoint, actually opposite upon hypotenuse. That's the only way. And by Pythagoras application, AB square equal to AC square plus BC square. BC, you will get BC square 3. So BC will be under root 3. Right? Okay? Clear in your mind? Example number 17, not in your textbook but from other reference book we have selected. Okay, now dear student, next one. Before I go for next example, I want to upgrade your concept a little bit for the purpose. See, now dear student, concentrate here. If I write formula of cot theta, can you tell me what is the formula of cot theta? Adjacent, you all know this very well. Upon opposite, you know this, right? I just want to give you one idea about a simple identity. Suppose, dear student, I do one thing. Here I write hypotenuse. To maintain the original form, here also I have to write hypotenuse. Okay. This is formula of which trigonometric ratio? Adjacent upon hypotenuse, obviously cos theta, dear student. Opposite upon hypotenuse, sin theta. So you got a new identity. Cot theta equal to what? Cos theta upon sin theta. Actually, this identity that you are going to learn when we do type 4 example based on only identities. Just now, for solving two main examples, you just need to remember, dear student, what is the actual formula? Cot theta equal to what? Cos theta upon sin theta. Please remember how we got it. First, we write the basic formula of cot, adjacent upon opposite, and we put the common denominator. Understand? So this is formula of cos and this is of sin. So what is the formula of cot theta you got? Cos theta. Wherever there is cos theta upon sin theta, you can call it cot theta. Is it clear in your mind? Now, dear student. So this formula I am just writing. Whenever you get cos theta upon sin theta, you can replace it by cot theta. So this you need to remember. Okay, for the two examples which we are targeting now. First, the example number 20. Read the example. What is given? If cot theta equals to A upon B, then find the value of cos theta minus sin theta upon cos theta plus sin theta. See, dear student, how we apply this identity. Cot theta is already given A upon B. Value we have to find. Let me write first. Cos theta minus sin theta upon cos theta plus sin theta. I want to utilize that identity here. So I want cos theta upon sin theta. Then and then I can take cot theta. So everywhere divide by sin theta. Cos theta upon sin theta. Sin theta upon sin theta. In the denominator in the same way. cos theta upon sin theta. And here also, dear students, sin theta upon sin theta. Now you all know very well cos upon sin, I can write cot theta. This is cot theta, this is cancelled 1. Cos theta upon sin theta, that is cot theta plus 1. Now let us substitute the values. What is value of cot theta? A upon B minus 1. A upon B plus 1. So this is now, if you take LCM, A minus B upon B, and here A plus B, just a simple cross. This is cancelled. So you got A minus B upon what you got? A plus B. Such a simple example, dear student. Just have a look how we utilize that identity, how we applied cos theta upon sin theta equal to cot theta to ascertain that I must get cot theta here. I divided each and every term in numerator and denominator by sin theta. How we got the formula cos upon sin equal to cot, that I already taught you. Okay, verify. Okay. Here actually, dear student, I do not wanted to utilize the concept of triangle a little bit. I want to just upgrade your concept by taking the cot theta identity. That's why only. Right? Okay. Now the next example which I am targeting also of the same type, and that is example number 21. There is little mistake in the paper, dear student. There I have written if P cot theta equal to Q upon P, but that's not. Actually make an improvement. There is if P cot theta equal to Q, that is only given. Then find the value of, read the sum, then verify. P sin theta minus Q cos theta upon P sin theta plus Q cos theta equal to P square minus Q square upon P square plus Q square. That's the example. Again, dear student, first, what is given? P cot theta equal to, P cot theta equal to Q has been given. If I just want to take value of cot, can I transfer P here? So what I get? Tell me. Cot theta equals to Q upon P. Is it clear in your mind? Now LHS. What is LHS? P sin theta. Now we concentrate here, dear student. Minus Q cos theta upon P sin theta plus Q cos theta. I have value of cot theta. To realize cot theta here, like in the previous example we have done, let us divide each and every term in numerator and denominator by sin theta. Here also Q cos theta upon sin theta. Here also P sin theta upon sin theta. Here also Q cos theta upon sin theta. Okay. Now see the next step which I am doing. Sin theta got cancelled. Here also what I am writing here, P minus C, dear student, this is Q. Cos upon sine, can I write cot theta? P plus Q cos upon sine, can I write cot theta? And now the value of cot theta you have equal to P minus Q. What is the value of cot theta? Q upon P, and here also P plus Q into Q upon P. Next step, this P as it is minus Q into Q, that is Q square upon P, upon, dear student, P as it is plus Q into Q, Q square upon P. Now you take LCM, this is P into P, P square minus Q square upon P. Here also P square plus Q square upon P, this is cancelled. So you verify P square minus Q square upon P square plus Q square. This turns out to be RHS. The sum is verified. Just look at the sum before I deliver you homework. Clear in your mind? See, dear student, last both examples I can also do by triangle equation method, where I will decide the two sides by the basic formula. Third, I may find by Pythagoras. Then I find sin theta, cos theta, I substitute. I can verify this way also. Understand? But if you just go on doing that way, the sum may enlarge a little bit. Rather, it is a little smart way to solve the same example. Here, you know, one identity we utilize, that's cot theta equal to cos theta upon sin theta, and that identity is very, very important for us. So both the last example we have adopted a little smart and short way to solve the example. You understood this, right? And this identity, dear student, you remember, will be helpful to you when we solve type 4 examples. Okay? So, dear student, in today's homework of lecture number 5 is, you will be doing, after attending the lecture, example number 17, 19, please note down, 20, 21, 22, 23, 24 and 25. So these 7 examples are for homework, and with this we are completing WP1, that means type 1. Now, dear student, in exam nobody is going to clarify for you that this is type 1, type 2, type 3, type 4, but type 1 we have done. Now when I start type 2, I will immediately give you the clue point why it is type 2. When we start type 3, I will give you the clue point why it is type 3. Clue point are for our understanding, right? So how can we demark and bifurcate type 1, type 2, type 3, type 4. That is our own way of understanding this particular chapter, which will solidify and make this chapter easier for you. So this is, dear student, we have just completed type 1. Okay, thank you very much.